We send millions of packets every single day across untrusted networks, such as the internet. And if we want to, we can add a little extra protection as those packets cross the internet by using a technique called VPNs, virtual private networks. And that's what you and I are going to discuss in this video. So let's use this topology to talk together about when it might be appropriate or really useful to have that extra protection of a virtual private network as we send traffic over other people's networks, including the internet. One of those situations is if we have a remote site that wants to communicate with the headquarters site over somebody else's network or over the internet. So the problem is that if we start sending packets over the internet that are just plain text, they're not encrypted or kept secret, anybody and any service provider or any router that's forwarding that traffic on the internet has the opportunity to eavesdrop on that traffic or possibly manipulate that traffic, which would compromise our security for the communications between those two sites. So in this case, what we could do is we could build a logical path. They call it a VPN tunnel between these two endpoints, between the router at the headquarters site and the router at the remote site. And here's what happens. Anytime traffic from the headquarters site is being routed to the remote site, the router is going to pause for a second just for that specific traffic and say, whoa, I'm going to go ahead and take a moment and I'm going to encrypt the traffic, make it protected, and logically send it through this tunnel. So when we say it's going to send it through the tunnel, what that means is that this router is going to encrypt the traffic and ship it over to its good buddy over here at the remote site so this router can decrypt it. So from the internet, it just looks like packets that are being sent, but behind the scenes, the payload of those packets is encrypted. So if we have any malicious actors on the internet who want to eavesdrop on that data or they want to manipulate it, they won't be able to do it successfully because the data is being encrypted by this router and then decrypted by this router, and only those two routers, being the endpoints of this VPN tunnel, have the ability to decrypt or make sense of the data. And this VPN tunnel is sometimes referred to as an SA. That's an acronym for a security association between this router on the left and this router on the right. And this type of relationship between these two routers, where they both agree to take traffic between these two sites and encrypt it and ship it to each other, that's referred to as a site-to-site tunnel or a site-to-site VPN. So if somebody asks us, well, how do we protect traffic between this site and that site if it's going over the internet? The answer is we could set up and configure a VPN site-to-site tunnel, which would encrypt and protect every single packet going between those two sites. And that's how we could do it, with a site-to-site VPN tunnel. Now, another scenario that we might want to use the VPN protection on is for an individual computer. So here we have Bob. Let's say Bob's at his home and he's got his PC connected to the internet. Perhaps he's using cable modem or DSL or some other method. He's connected to the internet, but if he wants to connect to the headquarters site, we don't want him sending packets just naked and unencrypted either, because once again, they could be intercepted or eavesdropped on by devices on the internet. So once again, we could build a VPN tunnel here from Bob's computer individually over to some device at the headquarters site. So to build that VPN tunnel from Bob's computer to the headquarters site, on Bob's computer we'd have software that he's running that would allow him to do that. And then at the headquarters site, we could have a device such as a router acting as the other end of that VPN tunnel, or we could have an ASA or a firepower appliance. Any one of those devices, if properly configured, could be the device at the headquarters site that Bob is using to connect to with his personal VPN. And when we build a VPN from an individual computer, that's called a remote access, or RA, VPN. So these are the two main categories of VPNs: site-to-site, for example, between the headquarters site and a remote site, and a remote access VPN, which is being started from an individual computer going to some other device, in this case a router at headquarters site, to build VPN protection for traffic from this user as it communicates with the headquarter location. So now, if somebody came to us and they said, hey, how do we protect packets as they go over other people's networks or untrusted networks? We could say we could implement a virtual private network, a VPN. And furthermore, we could say, you know what, there's two kind of categories of these. One is called a site-to-site VPN, if we want like site 1 to site 2, and all the traffic between those two sites to be encrypted and protected, we'd use a site-to-site VPN. And if we need to protect data from one individual user on their own PC, we would create a remote access VPN that starts at that PC and ends, in this example, at the headquarters site at the other end of that VPN tunnel. So now we know the two major camps or categories for VPNs, site-to-site and remote access. And in the next video, what I'd love to do is chat with you about some of the building blocks of cryptography. This is a fancy way of saying how VPNs protect each of those packets. And we'll cover that in the next video. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.